This video is going to be going over the Chapter 6, Test B. This is the practice test. The real test will be very similar type of questions, just different numbers. So let's get into this. The first one is write the word sentence. So you want to write the word sentence, which is right here. You want to write this word sentence as an equation. You don't want it in words, you want it in an equation. So I'm going to look here. I have a number x decreased by 18. Whenever I see the word is, I think of equals 3. So I start with my x because that's what I'm starting with, a number x. What's happening to x? It's being decreased by, which is subtraction, being decreased by 18, and it is 3. Now, we don't have to solve for x. This right here is your answer. Number 2, your friend has X pennies. Okay, so I'm going to do a little thing here. This is friend. Your friend has X pennies. You have, this is you. You have 29 pennies. You and your friend have a total of 40 pennies. Okay, so if I put my friend and mine together, I'm going to get a total of 40. And it says write an equation that you can use to find x. Now, this right here is an equation. X plus 29 is going to equal 40. Because if I put what my friend has and what I have together, which is addition, then I will get my total. It said I had a total of 40. All right, number 3. It says tell whether y equals 11 is a solution of the equation y minus 6 equals 5. So there's 2 ways you could do this. One is I'm just going to y minus 6 equals 5. I'm going to put 11 in for y. 11 minus 6 equals 5. Does 11 minus 6 equals 5? Yes. So it is a solution. Now the other way I could do it is y minus 6 equals 5. I could figure out what y is here. Minus 6, so I have to add 6 to that side, add 6 to that side. That gets me 11 equals y. So y equals 11, which is what it says here. So either way, your answer is yes, it is a solution. Number 4. So number 4, 5, 6, and 7 are really important, and I'm going to need you to do a few things for me. You got to show your work. So if you have x plus 6 equals 10, you don't have to circle the variable. It does help me see that that's what you want to find out. So I got to get everything on that side gone except for the x. So if I have a plus 6, I got to do the opposite. I got to subtract 6, but I got to do it on both sides to keep it in balance. And when I do that, 10 minus 6 is 4, and x, because those two cancel, x equals 4. So I have part of it. I have my answer. I think x equals 4. Now I'm going to come over here, and I'm going to rewrite the problem. This is going to be my check. So I think x is 4, so I put 4 in for x. 4 plus 6. And if that equals 10, which it does, it checks out. Okay? So I'm going to need to see this work here. I need to see what the variable is, and then I need to see you check it. That is all about showing your work. Something that you will hear from teachers a lot. All right, number 5. So we have g minus 6 equals 22. I want to find out what this g is. So minus 6, I got to do the opposite, plus 6. And I got a plus 6 on each side to keep the equation in balance. Those two cross each other out. You have g equals 22 plus 6 is 28. All right. I'm going to rewrite the problem, the original problem. G minus 6 equals 22. I think g is 28, so I put 28 for g. 28 minus 6, and 28 minus 6 is 22, so it checks out. Number 6. P divided by 3 equals 7. I want to figure out what P is. That's my goal. It's divided by 3, so I got to do the opposite of that. Times 3 times 3. That eliminates. So P equals 7 times 3 is 20. Oops. That's not good. There we go. 21. Now let's check it. So P divided by 3 equals 7. I think P is 21, so 21 divided by 3, that does equal 7. So yes, it checks out. All right, now we have one more. 3z equals 27. I want to find out what z is. Now, it's 3 times z, so the opposite of times would be divided. And I'm going to do it like this. And divide this by 3. So that cancels each other out. It leaves me z equals 27 divided by 3 equals 9. Now let's check it. So I write the original problem, 3z equals 27. I put 9 in for z, 3 times 9. And when I multiply those together, I do get 27. It checks out. Number 8, tell whether 7/16 is the solution for y equals 3x minus 4. So my equation is y equals 3x minus 4. And when I see something like this, 7/16, that is considered an ordered pair. And in an ordered pair, you have x is first and you have y second. So now I know this x represents 7 and the y is 16. So let's see if this works in here. The y is right here, so I'm going to replace that with 16. 16 equals 3. Now when a variable and a number are next to each other, I know it's multiplication. So 3 times x is 7 minus 4. All right, now this is still 16, but I got to do order of operations here, and the multiplication is first. So 21 minus 4. This side is still 16. 21 minus 4 is 17. 16 equals 17. That's not good. So this is not a solution. Not a solution. That ordered pair does not work in that equation. All right, number 9, the equation h equals 10d represents the height, so this would be the height, in millimeters that a plant grows after d days. Identify the independent and the dependent variables. We know variables are letters, so h is a variable and d is a variable. Now we have to figure out which one depends on the other. Now we can only know h. We can only know h when we know d, because d times 10 will give us h. So h is completely dependent on whatever d is. So my dependent variable equals h. Now days can be whatever. It doesn't matter how many. It's independent. It's free to choose. Independent equals the d. So d is independent, completely free. Once we know the days, then we multiply it by this 10, and we will get h. So we can't know h unless we know d. So the way to think about that is h is completely dependent upon whatever d is. And d would be your independent. All right, 10. This is a little tricky one. Didn't do a lot with graphing, but we've done some other stuff, and we'll do more coming up. So we have a little chart here. This is my little chart. It has time and distance. Now, when I look at a chart like this, I know that, I'm going to move this over a little bit. I know that this first box on top is going to be my x, and the bottom is my y. So I'm going to put this on the graph. If my time is the x, I know that this is the x. X right here. X marks the spot. So I'm going to label this as time. Then I have a y, and I know this right here is my y-axis. And so I'm going to label that distance. Now, I have to graph this. Of course, right here is 0 and 0. It's 0 over and 0 up. But let's look at this one, the time. We have a 1 and we have a 6. So we're going to need 1 and 6 on this bottom line. Because they're lower numbers, I'm going to go by ones. So 0 to 1 to 2 to 3 to 4 to 5 to 6 to 7 to 8 to 9 and to 10. Now, my distance, which is over here, it goes from 5 to 30. So that jumps a little bit more. This one, I think I'm going to go by 5s. I'm going to start here. 5, 10, 15, 20, 25, 30, 35, 40, 45, and 50. Once I've done that much, now it's not too bad because you just follow what you have in your chart. So if I have 1 hour, I go over to here to 1. I'm going to do this in blue. I go over to 1. I go over first. And then I have to go up distance to 5. So then I go up to 5. And it's right there. Now, the next one is 6 hours, 30 miles. So I go over all the way to 6. I get to 6. And then I got to go up to 30, which is right here. So that is right there. So then I have my graph line starting to be formed. The key is x and y, and you get the x, which is the time down here, and the y, which is the distance on that side, and you plug in your numbers, and then you graph it. Hopefully that explains that one fairly well. Number 11, write the word sentence as an equation. Okay, now we have another word sentence, but we need an equation. Okay, a number C is, I see that is word. I always underline is twice. The reason why I do it twice is because then it looks like an equal sign, which it is. Okay, a number C is 7 greater than, whenever I see greater than, I think of adding twice a number B. When anything is twice a number B, I'm thinking of multiplication. So this is the equals. So I'm going to put C on one side, C equals. Now I need 7 greater than. 7 greater than what? So this one has 2 little parts into it. So one is twice a number B. Twice a number B, that would be 2 times B. That's twice a number B. And then it says it's 7 greater than that. So now I got to go 7 greater. So I plus 7. And I have written an algebraic equation to represent a number C is 7 greater than twice B. So C equals 2B plus 7. Number 12. All right, we have the area of a rectangle is 81 square yards, and we want to write an equation to find what x is. So I will give you this formula: area equals base times height. So we have a base and a height. So let's replace what we know. Do we know the area? Yeah. 81 equals, do we know the base? It's x times, do we know the height? 9. So now, here's my equation. 81 equals x times 9. Now I just have to figure out what x is. So I want to get that by itself. It's times 9, so I divide this by 9, divide this by 9, and it gets me 81 divided by 9 is 9 equals x, and then those just cancel. So I think x is 9. I think that is 9. So let's plug it in and see what we get. Area equals base times height. I think the base is 9 and the height is 9. And it told me the area was 81. 9 times 9 is 81. It checks out. And so your variable is 9. And I will give you this formula if you need it on the test. 80s. Oh no. This is by far the most difficult question on the whole test. And I think I will give you a little chart to get you started on this one. My suggestion would be to make this kind of a chart, and I think this ratio table, and I think I might start this for you. We know that this is x and this is y. So x would be considered our seconds. Shoot. All right, seconds. We're just going to do like that. Seconds. And then this right here would be, the y would be push-ups. Okay. You can perform 6 push-ups in 16 seconds. So 6 push-ups in 16 seconds. Write and graph an equation that represents the relationship between time and number of push-ups. Okay, so time is going to be the important thing. Eventually, it'll say, at this rate, how many push-ups can you do in 2 minutes? So one thing I have to convert is minutes to seconds. So how many seconds are in a minute? 60. So how many seconds are in 2 minutes? 120. Now, what I want to do is I want to get it down to 1 second. So how do I go from 16 to 1? It's either multiplying or times. It's either multiplying or dividing. So you take 16, and if I divide 16 by 16, it leaves me with 1. If I do that to the top one, I have to do it to the bottom. 6 divided by 16, that gets me 6/16. 16ths. All right. Now, here's the tricky part. You have y equals something x. Now, x is your independent number. So, independent would be this 1 here. And the dependent is, once you figure out how many seconds, then you can figure out how many push-ups. So how do I get from 1 to 6/16? Well, anything times 1 is itself. So 1 times 6/16 is going to get me the 6/16. So let's just make sure that this works. So I'm going to suggest x is 1. And I'm saying this is my equation. So I have 6/16 times 1. What does that equal? That equals 6/16, which is what I have here. Okay. So my equation, and getting it down to just this 1 unit of 1 second, the equation is y equals 6/16 times x. All right. Now it says 2 minutes, which I know is 120 seconds. Now that I know x, I can put this in here to figure out what my push-ups are. So y equals 6/16 times 120. And I make that into a fraction. And then I go 6 times 120. That gives me 720 over 16 times 1 is 16. And if you do 720 divided by 16, it's going to get you y equals 45. So this will be 45 push-ups. Now, it says to graph it. And I will help you to set up this graph too. We know the x is seconds. So x is right here. I'm going to make that seconds. And the y, which is right over here, is push-ups. Push-ups. So 0 seconds will 0 push-ups. Now I look at my seconds. I have 16, 1, 20. Those numbers get kind of big. So I think I might do it by tens, maybe even by 20. Let's do 20s. So 20 seconds, 40 seconds, 60 seconds, 80 seconds, 100 seconds, 120 seconds, 140, 160. Okay, that'll be enough. Now, push-ups. 6/16, that's not even 1 push-up, and 45 push-ups. So I want to go from something up to 45 is my biggest number. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Now, if my x is 16 seconds, so I come over here, and it'd be like right in the a little bit, the halfway would be 10 seconds, so it's between 10 and 20, so I'm going to think it's right about there. So that's 16, and I have to go to 6 push-ups. So if I have 5 here, I'm going to go a little above that. So I think the first dot is about there. Now 1 second would be way here, and 6/16 is even less than 1 push-up, so it's like almost right there. But 120 seconds, I come all the way over to 120, and then I have to go up to 45. 45 is all the way up here. Okay. So in 16 seconds, I'm going to do 6 And in 120 seconds, or 2 minutes, I'm going to do 45. And you can see how the graph goes up like that. Okay. So I think what I'm going to do for you for your test is I'm going to set you up with this a chart like that. And I'll label this for you, label this for you. And then you can probably do the rest so that you can get your equation and then be able to graph some of it. Now that I have this equation, I could graph anything. I could even do 60 seconds. 60 seconds. Because now the x would be 60, so it'd be 616 times 60. That would equal my push-ups. So I do 60 times 6 divided by 16 equals 22 and a half. So that would be 22 and a half push-ups. 22.5. 22.5. So if I go over to 60, go all the way over to 60, then I'm going to go up. There's 20, 22 and a half, which is right in the middle there. So you can see I land on that line. But I can figure out anything. So I can kind of know that if I do 100 seconds, 100 seconds is going to be probably between 35 and 40 push-ups. All right, that's a tricky one. All right, number 14, this last one. The table shows the cost of playing several carnival games. You have $30 and play each game twice. How much money do you have left? So how much do I have left? I know that I have 30 to begin with. So there's a couple ways to do this one. I'm going to start with the way that makes sense to me thinking about this. It's kind of where you have $30 and then you're going to take away 2 ring tosses, 2 balloon pops, and 2 basketballs. So I'm going to do 30 minus 175 times 2 minus 250 times 2 minus $2 times 2. And that will get me how much I have remaining. So I have to do my parentheses first. 1.75 times 2, that's $3.50. 250 times 2 is $5. And 2 times 2 is 4. So now you have 30 minus 3.5 for the ring toss, minus $5 for the balloon pop, and minus 4 for the basketball, and it leaves you with 17.5. So all of this leaves you with 17.5, and this is going to be your remaining. So 17.5 equals your remaining money. Now the other way to do this would be to say, okay, I start with $30. So I'm going to have R. I have my remaining money, and I add to it 1.75 times 2, and then I have to add to that my balloon toss, 250 times 2, and then I have to add to that my basketball, which is 2 times 2, and that's going to get me what I started with. So if I take my remaining money, which I don't know what it is, and I add all of the games I played, it should total out to be a total of $30, because that's what I have. All right, so let's do that. So R plus 350 plus 5 plus 4 equals 30. Now, I see I have some like terms here. I'm going to add all of those together. 350 plus $5 plus $4 equals $12.50. So my remaining plus $12.50 equals what I have is 30. So now if I want to get what I have left, I got to take away this $12.50 here, minus $12.50, and I get my remaining equals 30 minus $12.50 equals $17.50. So I get the same thing over here as I get over here. It's just two ways to do it. I'm okay with either way. I just want to make sure if you do it this way, the first way I did, after you need to have some variable. So it needs to say equal R, R being the remaining. So you could set it up this way, or you could set it up 30 minus 1.75 times 2. Okay, then you're going to take away this one, 2.5 times 2. And then you're going to take away 2 times 2 and equals R. What makes this an equation is that you have a variable R here. And what makes this an equation is that you have a variable R here. They kind of say the same thing, just a little different, and either way is fine. Okay, so hopefully that gives you an idea of some of the things, and we've gone over these quite a bit. So the key for me with this test is the first page especially. I really want you to be able to 4, 5, 6, 7 to be able to solve for a variable and then to be able to check it and show your work. That's kind of the most important for me right now. So I will have those be a little bit higher of a value than some of the other ones, but and I'll also like to see how your mathematical thinking is going with the other questions. So let me know if you have any questions, and the test will be on Wednesday.